Confusion matrix. A confusion matrix is a table that is used to evaluate the performance of a classification model. It provides a summary of the predictions made by the model compared to the actual class labels of the data. In a binary classification setting, the confusion matrix has four components: true positives, true negatives, false positives, and false negatives. So if you ask me what is true positives, true negative, false positives, and false negatives, as you can see from a chart over here, when the predicted is positive and the actual is positive, we say it as true positive. And the predicted is positive and the actual is negative, we say it as false positives. When the predicted is negative and the actual is positive, we say it as false negatives. Whereas when the predicted is negative and the actual is negative, we say it as true negative. To give my explanation over here, so let me explain the concept using this example here. So we have orange and not orange concept, whereas if it is actually orange and if it is predicted as orange, we say it as true positives. Whereas if it is actually an orange, whereas it doesn't predict as orange, we say it as false negative. If it is actually not an orange and it is predicted as orange, we say false positive. Whereas if it is actually not an orange and it is predicted as not an orange, we say it as true negative. Next, we are going to see about the evaluation of classification algorithms. Accuracy, the proportion of correctly classified instances out of the total instances, which gives a equation as true positives plus true negatives divided by true positive plus true negative plus false positive plus false negatives. Precision is the proportion of true positives among all instances predicted as positives. Recall is the proportion of true positives among all actual positive instances. F1 score is the harmonic mean of precision and recall, providing a balanced measure. So from the equations that is provided as I explained for accuracy, each of the metrics here, such as precision, recall, F1 score, has its own formula with its descriptions. And next thing is receiver operating characteristic, that is ROC curve and the AUC curve, which is area under the curve. It is also a evaluating metric for classification tasks, whereas ROC curves plot the true positive rate against the false positive rate at different probability thresholds, whereas AUC measures the area under the ROC curve and provides a single value summarizing the model's performance across various thresholds. Higher AUC values indicate better model performance. Finally, cross-validation. Employ cross-validation techniques such as k-fold cross-validation to assess how well model generalizes to new data. Cross-validation helps to ensure that model performance is not overly influenced by the specific data used for training.